Hello there, I am LG Tiliwagan, and our lesson is about rationalizing denominators. But before that, please don't forget to hit the subscribe button. Okay, the process of eliminating or removing radicals from a denominator of a fraction is called rationalizing denominators. Here, rationalizing denominators or removing radicals is done by multiplying a suitable factor to both the numerator and denominator. We will be discussing three cases here. Case number 1. If the denominator is a simple radical, use the property nth root of b to the n equals b. So in this type of problems, you might be given a denominator with one single radical whose radicand is has an exponent that is not equal to n, okay, or less than n. So what you need to do is multiply it with a suitable factor so that its exponent will be equal to the index. For example, you have here 1 over the 5th root of x plus y squared. If this had been a 5, then we can simply delete 5 or delete the radical together with the exponent. But unfortunately, this is less than 5. So we need to multiply this radicand by a factor. And that factor is 5th root of x plus y cubed. Remember, with the laws of radicals, nth root of a times nth root of b is nth root of ab. So with this, 5th root times 5th root, or 5th root of something times 5th root of something, we can multiply the radicands. And when we multiply these radicands having the same base, we add the exponents. 3 plus 2 becomes 5. So the index, or I mean the powers of the radicand has been completed. Okay, it becomes 5. The index is 5. Using this property, we can remove the radical. Well, the numerator is just multiplied by 1, so it's just the same. Remember, we need to multiply both. We need to multiply the suitable factor both in the numerator and denominator. So it may appear that we are multiplying this by 1. So this is the final answer. Another example would be this one. You have a denominator that has cube root and then 100 x to the 4 y to the 5 z squared. Notice that your x to the 4, or your x has a power greater than the index. So you may write this as x cubed times x. Now the cube root of x cubed will be x, so it can be written outside. Y to the 5th as well. This can be written as y cubed times y squared. So that y cubed, cube root of y cubed becomes y. Okay, what remains is y squared. So simplify first this. 100 is 10 squared. Now you see that 10 squared needs a 10 to the 1 to complete into a cube, into a third power. X here needs an x squared, y squared needs a y, and z squared needs a z. So we multiply that here and as well as in the numerator to complete the numerator. I'm sorry, this one here should be cube. Okay, so after that, cube root of all terms with a cube, you can actually eliminate the radical 10xyz and simplify this with the terms on top. 25 is 5 times 5, 10 is 5 times 2, and you can also cancel x. The result would be this. Now you have case number 2. When the denominator is a binomial which contains either one or both of the terms having radicals of index 2 or square roots. So what you need to do here is this. Use this concept. Now the conjugates of these are conjugates, right? This is just the same in our special products. U plus v times u minus v is u squared minus v squared. So if you have radicals in your u, then since it is raised to square in your answer, the radicals will be eliminated. So here, as you can see, a square root of u plus square root of v times a square root of u minus a square root of v, the resulting answer will be square root of u squared, cancel square root and squared, minus the square root of v squared, cancel square root and squared. So what's left is a term without square roots. So if this is in the denominator, then you have eliminated the radicals, hence rationalized. Next example is this. You have a 2 over the square root of m minus 1 plus the square root of negative m plus 3. So simply just consider the conjugate of this, the minus, the binomial with the minus, and multiply it there. So multiply this with the minus here. So this one will be a u squared minus v squared. So as you can see, square root of m minus 1 squared, and this one will be the square root of this squared minus, okay, upon multiplying this 2. Then at the top as well, distribute this 2 there. You might distribute or not, okay, but the denominator really will be simplified. Square roots here will be deleted, so you get an m minus 1 minus negative m plus 3. Simplifying this, you get a 2m minus 4, or you factor out 2 from this and cancel with the 2 on top, then that will be the answer. Here it's not cancelled, but it's okay. The denominator still is rationalized. So take a look at this example. You've got a 1 over a binomial that has cubes. So we need to find the trinomial that suits this binomial so that we can arrive at this answer. And of course, this will be your u, this will be your v. So the pair there, or the trinomial, should contain a cube root of x squared minus uv. So cube root of x times cube root of 4 minus, because it's plus already here, and then the last term would be the square of this, cube root of 4 squared. Okay, multiply that as well on top. The denominator becomes the sum of 2 cubes, so the cube root will be eliminated, hence you get an x plus 4 at the bottom. Okay, you have only 1 on top, so multiplying that will be the same. Alright, next example. Instead of the binomial given, you're given with this trinomial, okay, here, but you have to check first if it follows this. So if your u is, if this one is a square, yes, this is a square, this is 3w squared, this is 2 squared, your middle term should be a uv, so this should be a 3w times 2. Okay, that's it. So you have identified your u and v, then multiply this trinomial by the needed binomial. This is plus, all plus, so you need the minus, this one. Remember, your u is 3w, your v is 2, so this guy here should be multiplied by the cube root of 3w minus the cube root of 2. Multiply the same on top, so that when you simplify, the bottom becomes a cube root of 3w cube minus the cube root, I'm sorry, this is cube root of 2 cube. You can delete the cube roots, so 3w minus 2. Okay, and what happens on top is we have a 3w minus 2 here. Oh yeah, when we deleted the cube roots at the bottom, we have a 3w minus 2. Common factors we can cancel, and we have a cube root of 3w minus cube root of 2. Okay, that's it for our review on rationalizing denominators. Up next will be lessons in calculus, limits. Thank you, and God bless you.